And when we define our g naught f itself is a function. Let's check out what does this pictorially mean. That is, A is our domain. Let's understand composition of function with help of an example which is visual enough for you to visualize. First of all, let there be a function, say f, and say f is pouring water, and we define it from A to B. So we know what is f is function, A is our domain, and B is our range. So let's define what a domain is. For example, A is collection of utensils in your home. Say you have a spoon at your home, and let's assume that is our object x1. You have glass at your home, so let's take it as x2. Say there's a tumbler, which is x3. And a bowl, x4. And a cooker, say it's x5. And say we have a bucket, and let's take this as x6. Now we apply our function pour water on the domain. So by saying fx is equal to y, what do we exactly mean? F we know very well is our function, which here we take as pouring water, and x is some element from the domain of the function. So by saying some element from the domain of the function, what do we mean? Here, domain of a function is all the utensils that we have at a home. So it can be any utensil from the collection. Say for example, we take a glass. Does that mean f of x is equivalent to saying take a glass and pour water in it? So we have y is equal to a glass full of water. Therefore, if we repeat the same process with all the elements of our domain, say we have a spoon, a tumbler, bowl, and what all utensils, we fill water in them because that's our function, right? And the range here is utensils full of water. Now, say we define a element y in general in the range. We have gotten y by applying the function on the domain, and domain is represented by x. So if we collect all these types of elements, what do we get? Our collection B, and B is our range. Let's define our function f pictorially. Let A be some set, and we take an element x in general from our set A and apply f. So what do we get? F of x. Say that element is y, and we collect all such possible elements, and we have set B, which will be called our range. Let's take another function. Say g, and let's define g as squeeze lemon. The function g is squeezing lemon, and we define g from B to C. So again, what is g? What's B? What's C? Let's understand domain in this case. Our domain is set B, and we know what set B is, right? It's collection of all y. That is B's collection of all utensils which are already filled with water. So we have a spoonful of water, say y1, a glass full of water, say y2, tumbler full of water will be called y3. So now we apply our given function. So g is squeeze lemon, so apply squeeze lemon on y. So g is again a function which is equivalent to squeeze lemons. Y represents some element from the domain of the function, which is some utensil full of water. Say for example, we take a glass full of water, And now g of y will be equivalent to taking a glass full of water and squeezing a lemon in it. So what do we get? The z. And z can be visualized as a glass full of lemon water. Let's take a look over the range that we get. If we repeat the same process of applying function g on all the utensils we have, which are already filled with water, what do we get? We get a set C, which we say utensils full of lemon water. We have Z1, which is a spoonful of lemon water. Similarly, we have Z3, Z4, Z5, and Z6. So let's understand range. We have all possible z. We already know z is defined as g of y. And when we take collection of all such z, we have our range, which will be called set C. So let's take a look at function g pictorially now. Our domain is B. We take an element in B, which is y. Apply g on our element y. And we get an element z, which is defined as g of y, which can also be written as g of f of x. And collection of all such possible z will be called our set C. Then composition of function is a function g not f. We start with f and then continue with g. And when we define our g naught f itself is a function, a is a domain, say is a range. And function here will be combined, that is pour water and squeeze lemon. Our domain is same as the domain of f, that is collection of utensils in your home. And our range for this function is same as the range for g, that is collection of all utensils full of lemon water. Let's check out what does this pictorially mean. That is, A is our domain. We take an element in general, say x, and apply g naught f, that is pour water and squeeze lemon in it. That is collection of all possible z, and z, as we know, can be written as g of y, and we already know that y is f of x. So z is equal to g of f of x, and the collection of all such numbers will constitute our set C. Now we come to a conclusion, and this is what a composition of function is supposed to be. Here ends today's class. But at the end, I won't leave you all alone. I'll leave you with some interesting do-it-yourself exercises, and let me know if you can solve all of them. If you can, that means you have exactly understood what composition of function is supposed to be.